Hi, I'm an old guy and I do maths, and today we're going to try and figure out what the surface area of this face of this 50-cent coin from Australia is. Now, I've made a previous video using this coin, and that was from a fairly controversial exam question that appeared in an Australian high school exam and made it to the newspapers in Australia. And given that I went to such trouble to get this coin so that I could demonstrate how simple that problem was, I thought I'd use it again. Now, it's a 12-sided coin, and that's important. It's got 12 sides. And as you will have seen in the header, I measured the distance from a point such as this diagonally across the coin to a corresponding point, and it was 33 millimeters. Now, what you will notice, if you haven't already, is that there are 12 equal sides here, which means that this is completely regular. And therefore, it is actually composed of these shapes, 12 of them. And the diagonal that I measured is twice this distance. So this is 16.5 millimeters. And because this is a regular shape, this is also 16.5 millimeters. And so we're off to a flying start, because the other thing we can do is we can work out what these angles are, because this is a regular 12-sided shape, and we can use a pretty simple formula to do this. The total of the interior angles of a shape like this can be found using this formula. 180 times n minus 2. Now, n is the number of sides. This thing has 12 sides, so it's going to be 180 times n minus 2, which is 10. So the total number of degrees on the inside of this shape is 1800 degrees. Now, what we need to do is we need to divide that by 12. And so 1800 divided by 12 is equal to 150. Now, that 150, if I can just add a little bit here, is all of that and all of that. So this angle in here is 75 degrees. Now, let's redraw that down here where it's nice and easy to see. That is 75, that is 75, and that's going to be enormously helpful. If we split this triangle, what we get is 16.5 there and 75 degrees there. We can find this this height, and once we find this height, we can figure out what the base is, and we can use that to find the area of this, double it to find the area of this, multiply it by 12 to find the area of our coin. So let's go to work. What we're looking for is we're looking for that. And so what have we got? Well, we've got an angle here, we've got an opposite and a hypotenuse. Opposite and hypotenuse is a sine. So the sine of 75 degrees is equal to the opposite, x, over 16.5. Now, we rearrange that so that 16.5 times the sine of 75 degrees is equal to x. Let's get going. And the answer is 15.94. We'll do this approximately. So x equals 15.94 millimeters. So more triangles. Just keep drawing and just keep working. Okay, so what we have is 15.94, 16.5. We can find this. So we'll call it x again. There are a lot of x's in this. 16.5 squared minus 15.94 squared is equal to 18.1644. I don't know if you can see that. And what we're going to do is we're going to find the square root of that. And the square root of that is 4.26. 4.26. Now, one more triangle. What we know is that the base here will be twice this, so I'll multiply that by 2, and I get 8.52 millimeters. The height of this is 15.94. Height times base divided by 2. That will give us the area of this, and we multiply that by 2. So 8.52 times 15.94 equals 135.8. Divide that by 2. And we get 67.9. Let's call it 67.9. So that is 15.94 times 8.52 over 2, and that is equal to 67.9044. Good enough, I think, to call it 67.9. Okay, so that is the area of one of these complete triangles. We multiply that by 12, and we get 814.85 millimeters squared. That is the area of the face of that coin. And unless I can think of something else to do with it, I promise to put that coin away, although it's a really interesting looking shape. So I hope you were able to follow what I did. Basically, I used a couple of very simple principles. This is a regular polygon, so all the angles on the inside of it, all of these angles will be the same. I figured out what one of those angles would be. This thing is constructed out of a series of triangles. The angle that I found was the total angle here, and so all I had to do, let me just get my pen into view. The angle that I found was the total here. All I had to do was divide that by 2 to get 75. Use a little bit of trigonometry to find that side, a bit of Pythagoras to find the base. Once I have the base, I've got the base and the height. I can find the area, and I'm in business. Simple as that. There probably is a slightly shorter way of doing this, but I thought I'd go through each and every step, and that's what we get. Thank you very much for watching. I hope you found this useful. If you did, or if you found it just interesting, please like and subscribe, and I'll see you next time. Bye.